aerodynamically the car is quite strong, and when we need to use more of that downforce in a wet weather setup, it's there, and again gives confidence. And I think anybody, when you're racing in the rain, confidence translates to lap time.
On this episode of Tuned In, we have Andrew Wojteczko, who is a team owner and race engineer for AWA, who are a team competing in the IMSA Sports Car Championship in North America. So for those of you who don't know us, it is Tim and Andre from High Performance Academy here. And today we are talking all about the GT4 platform in the sports car racing world. Really what's involved with getting the most out of one of those cars. These are cars that are all built in the factory. You essentially receive this brand new shiny thing with some level of documentation and said, good luck, go for it. And I thought one of the interesting things we talked about with Andrew was, what does that process look like when you receive this thing? How do you commission it? How do you understand it? How do you go about figuring out, which levers to pull to make this thing go fast?
Because the GT4 class is designed to be slightly slower, but a lot more cost-effective to run than the upper echelons of GT3 and GTE, I'm correct?
Yeah, absolutely. A lot more road car components that are used out of the box.
So on that basis, there is, as we'll find out as we talk to Andrew, a lot less tunability than the likes of a GT3 or GTE, but there are certain components still that are really important to dial in.
Yeah, I think on that, it was kind of quite striking talking to Andrew. It was very obvious that he finds himself quite limited to the number of things he says available to him. There was a lot of, if we had this, or I wish we had this, or if I could have one thing, it would be this. Yeah. But I think that doesn't take away from the engineering challenge involved. And I think maybe in some ways being more limited forces you into more creative, solutions and stuff, which I really like the idea of.
Yeah, definitely. And I think when you've got 100 different items that you can tweak or modify or change out, then the scope becomes almost limitless. And when you pare that down to a handful of levers that you can pull, then each of those levers becomes more important. And I guess the other aspect is the subtlety of the changes that you're making with those different components becomes much more powerful to the end result.
Absolutely. And I think that's probably very intentional on the part of the GT4 class. Overall, like you mentioned, that these things are cheaper to run. They're also supposed to be easier to run for a team.
Sure.
You want to make this as accessible as possible to as many levels of team. You don't want to have a whole team of engineers that can there to set the car up and to, analyze all the data that comes with it and all of the processes and procedures that you have when you've got a really sophisticated high-end sports car. So, by the sounds of it, that class is probably doing, what it was set out to do.
Yeah, I think we've seen this drive right through motorsport all around the world and across all classes up to and including F1, which is that constant drive to bring the budgets and the cost caps down so that more people can get involved. And I mean, GT4 definitely seems, as you said, like a solution to that problem.
It's a natural situation. If I look back at the genesis of GT3, I don't know, let's say 15 years ago even, some of the really, maybe it was 10, 15, I don't really know exactly, but those cars were essentially what we have as a GT4 car now, and you get that natural evolution. They start somewhere, and over time, whether it's
they creep.
Exactly, and now these even a GT3, which is designed as a custom racing platform, extremely expensive to run.
Yeah,
and I have no doubt that GT4 will end up in the exact same place, and we will have GT5 in a few years. I have absolutely no doubt. Yeah. But one of the things that we did spend, I wouldn't say a lot of time talking about, it was interesting to touch on with Andrew, was the role of bump stops as far as suspension tuning, and that really came into one of the tools that maybe isn't necessarily completely obvious to people that you would have. We talked about a limited number of things we could change. Based on some of Andrew's responses, we learned that he was maybe a little cagey about wanting to talk about some of that, which was, means we hit on a bit of a nerve, which was great.
It was interesting. Before the interview, we specifically asked Andrew if there were any areas that were sort of off the radar and he didn't want to talk about, and he had nothing. But yeah, as you say, clearly when we got onto the role of bump stops, that became a bit of a sensitive subject. So obviously there's a bit of performance to be gained there.
Yeah, exactly. And bump stops really are one of those things. People talk a lot about springs, dampers, tyre tuning, whether it's pressures or temperatures and stuff like that. And bump stops, really are up there with should be considered up there as, just as important as some of those other components. And people probably don't talk about them as much. So anyway, I think people will find that part of the discussion pretty interesting.
Yeah, absolutely.
And that ties in pretty well to an Instagram post that we put out not too long ago on the High Performance Academy Instagram page, which was all about the concept of bump to rebound ratio for your dampers. And this is something that whenever we talk about it, it tends to get a few people fired up. People love to tell us that we've got it all wrong and we don't know what's going on. But really what this is about is making sure that when you set your coilovers up and you set your ride height, that you are getting the dampers sitting in that right range of their travel, such that you've got sufficient travel in droop or rebound and bump/compression.
I think it goes a little deeper than that as well, because a lot of the enthusiast level coilovers that the street or weekend warrior are likely to be putting in their cars, people put them in without any real understanding of bump to rebound ratios, or even looking at where the wheel and tyre combination is going to sit at full bump, full compression travel. And then this sort of has the knock-on effect of moving into the main core topic, which is actually also setting our ride height, and the arguments for and against setting the ride height by adjusting the spring perch, or setting the ride height by adjusting the bottom mount on the coilover. So give us your take. The argument we always hear is that if we adjust the ride height by the spring perch, that's going to affect the spring rate. So
yeah, for sure. And this is something, I understand why people intuitively end up being a bit tripped up on this, because it kind of, I can visualize, I understand. Essentially what's going on is, for a linear spring, which is by far the most common type of spring you're ever going to come into contact with, whether it's in the aftermarket world or the motorsport world, a linear spring, all that means is that as you apply force to it, the step in displacement you get, or how much it compresses for a given amount of force, is constant throughout its whole rate. So
chuck a 10 kg per millimetre spring, if we're working in metric, put 10 kgs on the top of it, compresses 1 millimetre. Add another 10 kgs, compresses another millimetre, and so on and so forth. So the important point to take out of that is the spring rate never changes for a linear rate spring, no matter how much it's compressed.
Exactly. And the thing that really trips people up there is when people are often reluctant to make ride height changes on the spring perch, because it adds what people call preload to the spring, as in when the damper is fully extended. So let's say the car's jacked up, for example. So there's no weight on that corner of the car. You take the spring perch, you wind it up such that it's got a static compression on it when the damper is fully extended. And the misconception there is that by doing that you're going to you've now increased the stiffness of your suspension. Now, let me be very clear, that's not what you've done. It's the rate, as Andre said before, is constant regardless. What does happen is that you do have an initial force, an extra force or an additional force that needs to be overcome when the car initially sits on the ground. The reality is, for any practical combination of spring stiffness, car weight, that initial force is always going to be overcome by the static weight of the car. So as soon as the car's sitting on the ground, that initial force is overcome, and you really have no difference, certainly no difference from a spring stiffness or suspension stiffness perspective. It doesn't matter. Huge amount of preload, no preload, exactly the same stiffness.
Yeah, absolutely. I mean, there are other aspects we need to keep in mind. Obviously, it's not ideal to have the spring become non-captive at full droop, but there's helper springs or keeper springs to fix that situation.
For sure.
And I think really we'll finish this off by saying that the good rule of thumb to at least start with is that if we measure the overall amount of travel that our coilover or suspension provides, and we really want to start from our natural ride height position to provide about 2/3 of that travel in compression or bump, and the other third in rebound or extension. That's a good starting point in your book.
For sure. That's a pretty widely agreed position in the industry, certainly to start from. There's no reason you need to stay there 100% stick to that hard and fast, but it's a very good starting point. The other thing I think we haven't touched on here that we should at least mention is that the part of the other side of this equation, when people say, look, I'm not going to adjust my ride height at the spring perch because I don't want preload, they're doing it at that low amount. So a lot of modern coilovers have two adjustment points. One will be a threaded section on the spring perch, and the other is at the point where the damper attaches to whatever part of the suspension your damper attaches to.
Yep.
And our recommendation is to that low amount point is designed to set the wheel in the correct position and get yourself in that right travel window.
Yep.
And after that, all of your ride height changes should really be being made on the spring perch.
Yep, absolutely. And if you do want to learn more about that, we do have a complete course that covers motorsport suspension and wheel alignment, and we'll actually teach you how to perform your own wheel alignment. That sounds like it might be beyond the scope of a lot of people, but you'll actually find out through that course it can be done very quickly, very easily, and for not a huge outlay of cash using a string alignment system. If that sounds a bit backyardish, don't worry, you'll find that exact same system used right up to the highest echelons of motorsport. So you can check that course out, and you can also purchase it using our coupon code podcast75. That will give you $75 off your first HPA course, and we'll chuck a link in the description that will get you through to that course. I think with that out of the way, Tim, let's get into our interview.
Let's go. So we've got Andrew Wojteczko here. Andrew is a team owner and race engineer for AWA, that are a Canadian sports car race team that compete in the IMSA Michelin Pilot Challenge. Welcome to the show, Andrew. Great to have you here, mate.
Yeah, great to see you guys.
So tell us a little bit about where you're from, Andrew, where you're based, where you went to school, what you've done, to how you got to where you are now.
Sure. So I'm located in Caledon, East Ontario. That's where we run the team out of. So I went to, my engineering degree I did at Ryerson University in downtown Toronto. But probably before that, my dad kind of gave me a really cool start into all things mechanical. And I remember from like grade school stuff with science fairs, and I wanted to build all this stuff. And he was like, before you're going to start cutting in material, you're going to draw it in CAD. And I was like, no, we don't need to do that. But he pushed me to, learn CAD at a really young age. And I remember building like RC hovercrafts and all this cool stuff for like school science projects. And then, when I was like 13, I was really into skateboarding, and, a lot of friends stopped cracking decks all the time on big stair drops. And I was like, I want to try something different. So I was keen to make these aluminum skateboards. And I remember my dad getting like right behind me and, started this business, and, all of a sudden, like, helped me get the CNC mill in the, the little 2-car garage at home. And I was, producing these aluminum skateboards, and it never really went anywhere as like a big business, but it was certainly a great learning experience. And yeah, I think, having access to, that type of equipment and knowledge, and, being given those opportunities definitely helped open, the path to where I am today. So, I went to, my engineering at Ryerson, and was pretty keen to get into the FSAE stuff, the Formula SAE program, where you build a, less than 600 cc single seater. Did that there in my first year, left that alone for a little bit, and then came back to it once I kind of got my studies sorted out for my final year, and really fell in love with it. The team element was super cool. I got to work with the lead suspension designer on that build, and then also drove. And we ended up with a top 10 at Detroit when that was still the competition with all the schools before they split it into the East-West. So was just an amazing experience. And while I was at Ryerson doing that program, I was getting into cars as a passion, and I started doing some Solo One, some like time trial stuff, and was doing pretty well with that in the driver capacity. And then coupled with the engineering stuff, it was all like fitting together quite well. And by the time I was finishing up school, my dad and I had started to build our first road race car. So we built a race prep shop at the family home, and started building our first road race car. And we built this 944 turbo. And the year I graduated, we campaigned that in the Ontario Super GT Championship, and not much competition, but won the championship that year, which was super cool. And I remember at that time watching like the Speed World Challenge and absolutely loving every minute of that, and just wanting to be a part of that. So we made a switch to a touring car program for the next year, and started developing these Lexus IS 300s. And we had the benefit of starting from some work that had been done by a previous team with some factory support. So kind of, bought everything used for 10 cents on the dollar and started going with that, running in the Canadian Championship with the goal of doing the World Challenge stuff. And that's kind of where we, spent the next 4 or 5 years running the Lexus program. And I feel really fortunate to have done that at that time, because I feel like that era has passed. That was the time when we were still building cars. We were building tubs, and had a little more freedom to design and build than we do today. And got to learn a lot of things the hard way.
So now you're really focusing more on a factory-built race car?
Yeah, exactly. So today now with homologated race cars, the manufacturers are tasked with the build, and any changes or anything we need now, we really need to channel through our manufacturer, force it through the homologation process, and that way it keeps a uniform, even playing field for the competition. But you don't learn the same amount as an engineer that I feel that I had the opportunity to learn when we were building the cars. Mm-hmm. It was expensive. It was time intensive, because you're learning things through testing, development, and failure, which as an independent team is a difficult way to do it. But I don't regret it at all. I feel like those years that when we were doing kind of everything as a small team, from designing, building, campaigning, driving, I think that what I've learned there has really helped open doors, every year thereafter. So I'd say it was probably 2009 when I made the decision to stop really pursuing the driving goal. And I definitely think from through university and then those, 4 or 5 years after, had the hopes of the pro driver route and was, chasing that. And the more I got to understand what was involved with that, the more I realized that it wasn't sustainable for me and that wasn't the right path. And I still wanted to be active in the sport. And that's where, the engineering side really allowed me to do that. And, from then on, started doing freelance engineering for teams with a, RSX and Canadian touring car, and then a Formula 2000 in the US F2000 championship, where we got the win with Remy Audet there, the overall, which is pretty cool. From there to GT3 Cup with Speed Merchants and Jim Hodnott. Got to meet some amazing clients and really started to understand customer racing there. He ran a great program, and I learned so much from him. And again, that really helped to, just 1 year at a time, kind of understand the sport better and, continue to open doors. I also did Continental Tire Sports Car Challenge program that year, where I was engineer and strategist for Ashley McCallum and Brett Sandberg with CKS. So I was doing those two at the same time. And, that was kind of my first chance to do strategy and start to understand the endurance racing side of it with the 2-driver lineup, and just started to realize how much I had to learn there as well. From there, when Speed Merchants decided to close up, one of the clients that was racing with them wanted to, continue, and that was Anthony Mantella. So I spoke to him and we put a program together, and that was the birth of Mantella Autosport, and really the first program that I was running full time. We started with Aston Martin from Multimatic, and that was 2014. So put that program together, and then we ran in a host of different cars over the next 4 years. So from the Aston Martin to the Z28R Camaros from Pratt & Miller to the KTM Crossbows, got to experience a whole bunch of different platforms, and it was a really good experience that way. Again, got to grow and understand a lot more about the team manager role, which I think helped prepare me for where I am now. Where once Anthony had decided to wrap that up, that was ready to step on my own 2 feet and start my business. And here we are today with AWA, and it's our 4th year now already since we started it.
So tell us. So AWA, you guys are a single car team and running in the IMSA Championship. Is that right?
That's it. Yeah. Michelin Pilot Challenge, single car, McLaren 570S GT4.
And tell us a little bit about how IMSA works. There's a few different tiers of IMSA, and obviously it's multi-class in each one of those. So where do you guys fit into the mix there?
Sure. So within the Pilot Challenge, there's the GS class and the TCR class. GS class being the faster cars, they're GT4 based. TCR being the touring car class. We run all at the same time, but are scored separately. So 2 classes in the Pilot Challenge. And we race on all the same weekends as the WeatherTech Championship, which is considered the top tier. In IMSA, they do the 24-hour Daytona, the 12-hour, where on those weekends we'll do a 4-hour or 2-hour. That's kind of how the structure in IMSA is laid out. Those are I'd say the two main series with the WeatherTech and then the Pilot Challenge. There are others, some single make stuff, and then the LMPC, but I think that's the bread and butter anyways. Yeah.
And is you guys run different race formats, is that right? Like some shorter races and some longer races?
That's correct. So we'll do a 4-hour at Daytona and then a 4-hour at Watkins Glen. All our others are 2 hours.
And just to come back to the WeatherTech series as well, so that's where people viewing would have seen the faster cars, GT3 and GTE. Those are competing in the WeatherTech series?
That's correct. Yep. So here they'll call it GTD, which is your GT3-based cars, and then GTLM, which is the GTE category cars, and then the prototype classes.
Okay, yeah.
Just for interest's sake, could you give us a bit of an indication on what the different relative lap speeds are between the likes of your GT4 and maybe the GTLM at the sort of at the top of the pecking order? Obviously, lap times are going to vary depending on the track, but can you sort of give us maybe a percentage difference?
Yeah, just thinking through some sample tracks here where we're at relative to the GTD cars.
I mean, I would have thought you're probably in the 5% sort of range we're talking about there.
I think that'd be fair. Yeah, to the GTD.
Yeah, and then GTLM's what, probably
that sounds about right.
1 to 2% faster again, but you've got all pro drivers in that class, and that's kind of part of the mix as well, right?
Yeah, absolutely.
And so, can you tell us, just for maybe people who aren't as familiar with sports car racing, what is GT4? How does that work? What are the cars based on, and how does that work for a customer racing team like you guys?
Yeah, so the GT4 category is made up of a host of different manufacturers. Most of the manufacturers are there now. So you have everything from Ford Mustang, Chevy Camaro, Porsche Cayman, Aston Vantage, our McLaren 570S GT4. What else is running there right now? I think that's the bulk of the field, but I think any manufacturer that has a suitable sports car can entertain having it homologated for GT4 competition. The big difference between GT4 and GT3 is its target lap performance and then its cost. GT4 cars right now are around half the price of the GT3 hardware. And then, like you said, about 5% difference on the lap speed.
I assume you're also looking at a substantial saving in actual running costs per racing kilometre for GT4 compared to the likes of the GTD or GTLM.
That's it. There's a cost per kilometre savings, but then there's also a significant reduction in running kilometres on a Pilot Challenge Championship versus GTD and WeatherTech. So, we do, I think, 24 hours of race time in a full season where, GTD car will do that at Daytona alone. So when you start looking at it that way, the mileage difference is substantial, and that's where a lot of the cost is.
And how close to a road car is your McLaren?
Our McLaren is closer to the road car than most of the other cars in the category, and I think that just stems from it starting from a supercar platform that a lot of the road going components were at a fairly high level to begin with, and also its cost was quite high to start, so they had to be conscious of that when deciding what to change to full-on race parts and what they didn't. The Mustang that we campaigned had proper race engine, sequential gearbox, other stuff, with full motorsport harness and stuff like that, Motec PDM, where that car was, truly a full-on race car, where our McLaren uses full-on production wiring loom. It's the standard engine. It's standard ECU and electronics, no PDM, nothing the likes of that. So slightly different way to achieve the same result, really. Each have their strengths.
Obviously, there are quite a few race sort of components on it. You must have like dampers, brakes, stuff like this, some suspension stuff. Must be quite different. Is that right?
Yeah, still a decent amount of updates on it. It uses all the standard wishbones, just with a low friction bushing as opposed to like a rubber compliance bushing on the road car. Brakes have recently been updated with a different variant. So within these GT4 cars, you'll see some different variants approved in parts. So sometimes we'll have options that allow a car to be better suited to endurance racing, like IMSA. So now we have a proper Alcon high volume pad, which wasn't the case before. What else? Yeah, Penske dampers on the race car, which are unique to the GT4 as opposed to the road car. But powertrain wise, it's all mostly road car components. Not many changes.
You mentioned earlier about not really having much technical freedom compared to, say, what you might have 10 years ago, or where you can build a car of your own. Is there actually anything on the car at all that you can build, or is essentially everything must be bought off the shelf?
So when it came to adapting it for IMSA, we were doing fabrication work to get like the right side nets and to meet all of the IMSA requirements for stuff like that, because the car didn't ship with some of the stuff to meet those regulations. All our setup equipment we design and machine and fabricate. So that's something, while we can't make much on the car, we still spend a lot of time with all of our equipment and anything we can do to improve our processes and stuff like that. We kind of channel our energy into that side of it. So being able to do quicker setups on the pad and good consistency there, things like
makes
that.
Sense. And you guys obviously have a bit of equipment in-house to be able to do that yourself?
Yep. It's a small shop, but it's got a lot of capability. So we have a full metal shop, fabrication and machining. We have a wood shop, so we can do patterns and work upstairs. And then the dedicated car shop. We've got shock dyno in-house. So anytime we need to make something, we can typically turn it out right in our own facility.
There's so many different cars running in the series. Understandably, there's going to be some inherent performance advantages and disadvantages in certain areas. So we hear a lot about BOP, or balance of performance, and can be a little bit controversial, I guess, from time to time. But can you just talk us through sort of broadly what BOP is and how it's applied to the cars?
Sure. So BOP is a balance of performance, and it's a difficult task that the series has to face because, everybody wants to win. So anytime, manufacturer isn't on the top step, well, they want to know why, and, they're going to be going to the series and trying to, lobby for performance. So it's a difficult role that the series is tasked with there. What they do is look at the displayed performance. So they will take the previous event, they'll review the performance of all the cars, and they will come up with a percentage plus or minus whether the car was too strong or not performing well enough. And then based on that, they will make an adjustment to the cars for the next event. So tools that they have to work with are mass, power, alignment limitations. Those are the bulk of them, and they will determine which variety thereof they'll apply, and it's car specific on what each car can or cannot do. Some cars have the ability to do different engine maps for higher or lower performance, where others don't have that option, and that's partly just part of the GT4 class, where a lot of road car components are used and don't necessarily have the ability to do map switching or power stick stuff like that.
Just in terms of...
That's what they do. And when you look at it, it's a competitive and close series.
In terms of getting a specific lap time, there's obviously a few different ways that can be achieved, and you can have a car that's stronger in top end speed and loses a little bit in cornering. So when they're applying BOP, are they trying to establish a consistency in terms of just the overall lap time and how the individual cars get that lap time doesn't matter? Or are they actually trying to maintain a consistency in terms of cornering performance and straight line speed between the different manufacturers?
Yeah, so they'll break it down into, low, medium, high, and high speed, and put a weight on each of the ranges. So what they're trying to do is make sure it's not just lap time parity, but raceability parity. Because, like you said, you can have a car make lap speed in different ways. But not necessarily race well together that way. And I think that's important that they consider that aspect of it. And that way everybody has a good chance to put on a good show. Whereas if you have the one car that's got all the straight line performance, that's advantageous for passing situations and can potentially defend in the low speed section. So yeah, it's not easy to get that evened out all the time, but I think that's definitely the goal.
Generally, when it comes to parity, there's not too many people that end up happy with the overall result, particularly if you were on the top step of the podium and all of a sudden you're facing some BOP penalties. But in general, is it assumed that, or is it understood that they're doing a pretty good job with getting the parity right?
Yeah, I think so. I mean, when you watch the broadcast, I think the racing is close. When you look at the times, the spread is close as well. And I hear this frequently, that the IMSA GT4 category is regarded as the most challenging and hardest fought GT4 category worldwide. And that's just really cool and special to be a part of. So I have a lot of respect for the people that are making these decisions and understand that, they're under a lot of pressure to get it right. A lot of people are investing a lot of money to be there, and everybody wants to feel they have a shot at it. But at the end of the day, the sport is only going to allow one winner, per event, and it can be challenging for sure.
Is that process that they're undertaking, is there any subjectivity in that, or is the formula that they're using to balance the cars, is that exposed to you, or is that essentially just secret and you don't know what calculations they're doing behind the scenes?
We get to see less of it now than we used to. So we just have to trust that they're, making good decisions for the right reasons. And I think I feel like they are doing a good job with that. So yeah, before we used to be able to see more of the sector times, but it allowed the teams to understand the BOP process maybe a bit too well. So IMSA elected to reduce what we can see to try to prevent that from happening, and just to allow the racing to happen naturally and for them to get an accurate read on what's going on.
So let's get a bit more into the topic we really want to dig into today, which was really just a bit of a general overview on car setup and philosophy and stuff. So for a start, what sort of setup changes can you make to your car? What sort of things can you tweak on the car?
So adjustable dampers. So we have two-way adjustable damper on the 570, bump and rebound. Our alignment is open as long as we're meeting our minimums. So we have a minimum ride height, which that changed coming into the next event for us. But as long as we meet the minimums when we pass through tech, it's up to us to determine what we want to do for how low we want to run and chassis rake and that. We have adjustments for alignment within bounds by Michelin. So Michelin will set a maximum camber that they feel is safe to run the tire at. We have to abide by and stay, below those values. But outside of that, we have control over our cambers. Our toes are completely up to us. Any roll bar positions, wing positions, and that is the bulk of it.
Yeah. And when you say that Michelin control, well, they obviously, it's pretty normal for a tyre manufacturer to come in and say, here's the toe and camber the maximum toe and camber that you can run. Does that become part of the scrutineering process for you guys as far as being disqualified, or it's more, it becomes an argument between you and the tyre manufacturer where they come and tell you off for running too much camber?
It was originally an argument with the tyre manufacturer, but it has now been established and enforced. So our upper limits are our upper limits.
Got you.
Do you also have a minimum on tire pressure as well?
They do provide minimum pressures, but they've been focusing on the cambers more so. But yes, there are pressures and camber limits specified by Michelin.
And are they coming? Do you guys have TPMS on board, or are they doing this with a pressure gauge? How are they actually checking the pressures you guys are running?
They used to be in our box, but since COVID, I haven't had a Michelin tech with us.
Mixed blessing.
Yeah.
So they were doing it just with they were just doing it with a pressure gauge before. We do not have TPMS on the McLaren. Some of the other cars in the series do, but no, we do not.
Yeah, okay. And that actually brings up another question I had about that. Do you guys have telemetry, or is that not allowed for your series?
We are not allowed to transmit live data from the car. So strictly logged on the car and then downloaded after session. So we rely heavily on the driver to communicate what they're experiencing and anything coming up on the dash because we can't see it on the box.
Yeah, got you. So as far as setup changes, we've gone through a little bit about what you guys can adjust. Is there anything on the car that you can't adjust that you would particularly like to be able to adjust?
I'd really like to have adjustments with the diff, but our car runs an open diff and we have nothing we can do there. So from working with cars with easily adjustable diffs and then even ones where you had to take them apart to make the changes, it's very powerful and very effective. And to lose that is sometimes you're just not working with all the tools. So that would be something I would...
Are they using anything tricky like applying the inside brake out of low-speed corners to sort of give an LSD effect, or is it literally just an open diff and wheel spin is a potential problem?
It does use stability control. So setup-wise, it's something we need to be mindful of. If we're too aggressive on the setup, we can induce excessive stability interference. And slow the car down unnecessarily and also use up rear brakes. So, it's something we need to be mindful of. It's, again, because this car doesn't use a full-on Bosch Motorsport ABS and traction control, it has a lot of the road car tendencies in some of these areas. So it is something that I need to be mindful of when I'm doing the setup to not get too aggressive and not... make sure we're not inducing too much wheel spin.
And I assume the mapping for things like stability control, traction control, this is, I guess, race car specific? This isn't what they're using in the road cars?
The track mode is, from what I understand, altered from the road car. So, it is specific to this, but we still have kind of the same adjustment range as the road car as far as, we have a sport track that we can pick from. So we will use some of the other modes in severe wet weather. And I've got to be honest, the car is phenomenal in the rain. So what they've got there does work well. And once we've understood it, even in the track mode with its limitations, I think once we understood it and know how to work with it, again, it works really well. And it's something that, both of our drivers are able to work with. And, Ori that typically starts our races, and qualifies, he's felt very comfortable in this car, where when we were in the 718, didn't have as much confidence. So this car seems to suit him very well. And he's done an absolute bang up job in it. He put the car P2 at Sebring in qualifying, his best ever, which, that was pretty phenomenal.
When you say the car's great in the wet, what do you think it is that makes it great in the wet? What sort of characteristics or qualities that the car's got makes it so good in the wet?
I mean, if we go back to basics, it's a low center of gravity car with decent track width, wheelbase, so it's got good stability and low load transfer to begin with. All things that you'd love to have in any race car. So I think we start with a supercar platform that meets all those requirements, and I think that's a big help there. Aerodynamically, the car is quite strong, and when we need to use more of that downforce in a wet weather setup, it's there, and again gives confidence. And I think anybody when you're racing in the rain, confidence translates to lap time, and having that is a big help. And then I think that the stability programming that's in it works well. It does a good job to again give driver confidence and allow to run good lap speed without big mistakes. So I think that's a big part of it.
Mm-hmm. Some of the factory stability control, traction control, and ABS can prove to be somewhat overbearing when you take that car and put it on a racetrack. It sounds like from what you're saying there, that works exceptionally well in the wet. But it sounded like you're maybe insinuating that in the dry, you need to be a little bit more mindful of staying away from some of the electronic assistance. Is that correct?
That's it. Yeah, if you drive into it too hard, if you've got too much yaw in the car coming off a corner, it's going to derate. And there's a time where you'll be back before you're back to full throttle. It's not the same kind of like ignition cut, instant on and off that you would have with a more advanced race traction control. So there's some time delays before it restores full power. And you can induce that sometimes by using really aggressive exit curbing, or by driving the car too aggressively. And if it's sideways, it's going to start to pull that out. And that's where the drivers, we're really lucky. Our pro Kuna Whitmer's got a lot of time in the car and has a good understanding for how to get the most from it. And I think that's shown this year with the performances. We've got he just does a great job in there, and we're really lucky to have him with the program.
And when you say having too much yaw on the car at exit, you're essentially saying trying to stop the drivers sliding the car too much at exit, to sort of hanging the tail out too much.
Yeah, exactly.
Yeah. So it sounds like that'd need to be pretty.
It's not the fast way to drive this car.
Sounds like they'd need to be pretty. I guess you have to be pretty mindful on the way you're driving it. Almost even a little bit on the side of being a little unnatural, as far as having a bit of restraint.
I think just smooth with the controls. It rewards smooth inputs. Yeah.
Now, what about logged data on the car? What have you guys got available? What system do you guys use for a logger? You said you've got no telemetry, but you can log a lot of stuff. So what system are you using, and what sensors have you got on board?
Motec C125. And that was something we fitted. So we did all the installation and, talking about things that we can do on our car. This car comes without a data system, and Motec is my brand of choice. So that's what we fitted. We run the C125 with the Motec camera. And then as far as sensors go, we run brake pressure, throttle position, steering position, yaw, the typical engine stuff. So temps, engine temp, water temp, oil temp, clutch and gearbox temp, low temperature, like intake air temp. Mm-hmm. And then for our own purposes on private testing, we run shock pots. And that's something that I find is extremely, extremely helpful. And we're not allowed to use it on the IMSA weekends, but something that we do run for all our private testing.
And does that sound like the teams actually have a little bit of freedom over which system they want to use?
Yeah, it's not series mandated. So if we wanted to run a PI or something else, that would have been up to us. We do have to submit our data after our qualifying and race sessions from our onboard logger. But as far as which system we use, that's our choice.
In terms of getting the engine data out of the car, are you doubling up on sensors, or are you able to freely interface between the C125 and the McLaren ECU?
Yeah, so the car's fitted with a FIA 6-pin CAN data plug. So we're able to connect to that, and then with the right template, we can read all the stock sensors off CAN.
Is that something McLaren and the other manufacturers are forced to provide, or they've just been happy enough to help you out with that?
No, for the homologation, you have to have a certain amount of information on the bus that's available at that data plug, so that the series are able to monitor and manage that correctly. Yeah.
Right. So that's a relatively standardized thing, I guess, between a lot of those GT3, GT4 cars. Yeah.
Yeah.
Got you. Yeah. And you mentioned there about shock pots. So what and how useful they are when you go testing. What sort of things are you looking at? Is this about understanding things like ride height, or are you more looking at how the dampers themselves are behaving? What are you doing with those?
Yeah, looking at bump stop interaction, understanding the heights relative to that, and then using the histograms to see our high speed, low speed balance, and then checking for anywhere that we're potentially hanging a wheel. Again, really helpful for that. Looking at roll stiffness distribution front to rear and trying to find that window of what works, because one of the things we can change is spring rates. We have 3 homologated spring packages for the car. So understanding where the car is in a happy window, where it's working well, and then able to validate that with the damper sensors.
Yeah, and that's a good point you bring up about roll stiffness distribution. For anyone who's not sure, it's essentially looking at the relative stiffness and roll between the front and rear axles. But do you find that's something you're changing quite a lot from track to track, or the car more or less has a roll stiffness distribution window that it likes to be, and you're not really deviating too much for it? You're just sort of moving up and down that spring package in front and rear as you go.
Yeah, once we got the car into a window that we were happy with, we're not making big changes there. If I had some stiffer options, I would certainly be testing them, but I have to work with what's homologated, and that upper limit is where we're running. So
yeah. And as far as, so if the springs sounds like you're more towards the higher end of the spring package, do you have a lot of effectiveness on your anti-roll bar adjustments, or do you find they're not too helpful?
Got position 1 or position 2.
So heaps of adjustment.
Yeah.
Is there a difference between position 1 and position 2, or is it?
Yeah, okay. It's significant.
Okay.
Yeah.
And is that working on a blade, or sort of adjusting the length along the anti-roll bar link, or?
That's it. Yeah, just changing the lever arm length. The whole position.
So your driver's making adjustments to those anti-roll bars to account for fuel burn during a stint, or is it more an overall setup change and that stays to get the balance right for a whole stint, irrespective of fuel load, for example?
Yeah, I mean, if we were allowed cockpit adjustable bars, then we could chase fuel burn and the like. But because it's actually about a 6 to 7 minute adjustment in the pit lane, we don't have that luxury. So we've got to set it to work right for its application, whether it be a sticker quali run or a long race run. We get one shot at it, and try to get it right.
Yeah, sorry, I'd assumed you had in-cabin adjustment there.
You
talked about looking at your damper histograms. Do you have a very wide range of adjustment on the dampers? Is that something you can revalve if you need to, or is it really just a case of changing the clicks on the dampers themselves?
So we are not allowed to revalve. The shim stacks, the curves are homologated. So we have to be within that window. So it's with the Penske damper, it's a needle and seat. The fronts do run a fair bit of compression, and when you run the bigger shims in to make those values, the adjusters start to become fairly powerful. When I build Penske's, if you build them soft, your adjustment window is really small. The needle and seat type adjustments don't really seem to respond well to a soft valving. But in this case, the updated valving that was released for the car in 2019, up front has a fair bit of compression in it, and the changes are significant. And then consequently in the rear, we have a fair bit of range on rebound control, and that's a powerful adjustment. So I think a lot of it's been just characterizing the car and learning what works, and
And the adjustments you do have, are these essentially low speed only adjustments, or it tends to affect it through the whole range? I think you said you had 2, a compression and a rebound separate circuit. Yeah,
so it's only a single adjustment, but I'd call it a global change. I wouldn't isolate it as a high or low speed change. It's definitely impacting the full range.
Mm-hmm. I think I'll just actually step in there and just clarify for anyone listening as well who doesn't understand the high speed and low speed. We're not talking about vehicle speed. It's the speed of the damper movement. And Tim, you're probably better to actually talk just really briefly about low speed and high speed versus how that affects the damper.
Yeah, so I mean, typically people, jump in here, Andrew, can be interested to hear your thoughts, but I would say the low speed side of the damper equation is more about controlling the transient handling of the car, more of the mechanical aspects of it. When you've got when you're looking at the high speed circuit or the high speed part of the damping curve, it's more about dealing with bumps, potholes, curbs, stuff like this, the handling over these really high speed events. Whereas I would say most of the low speed behavior is more about braking, accelerating, rolling the car in and out of the corners. You'd agree with that, Andrew?
Yeah, absolutely. I mean, typically we'd be making a low speed isolated adjustment for, driver feedback. The things the driver's feeling are typically going to be low speed stuff. Like you said, pitch, roll. But because we only have the single adjustment, we've got to find that compromise between, maybe we need a bit more low speed, but we're taking high speed with it. And is it a net gain or loss? And that's just kind of the nature of a single adjustment, right? It's not going to be right every time. And
are you typically, like you mentioned, the aerodynamics are quite powerful on your car as far as GT4 cars go anyway. Do you tend to use the dampers more for mechanical based reasons, or are you also trying to influence the inclination of the floor and to the ground and all that stuff, which is obviously a pretty big part of the aerodynamics? Or is it much more of a mechanical perspective you're using the dampers for?
It was just a matter of learning the car and how it behaved. Once we started getting some time with the car and understanding it, it became clear that, especially with the rear shock change, it behaved more like an aero car would than a mechanical grip car. So it was just learning what it wanted and how it would respond to the change. And that's just kind of, in my notes and understanding of, if I'm trying to, say adjust a entry understeer condition or something like that, which way I need to go. But yeah, definitely aero sensitive on the damper adjustment for the transient phases.
And when we're talking about aero there, it's really about just trying to keep the floor of the car within a certain sort of ride and pitch and roll window. Is that, you'd agree with that?
Yep, absolutely.
Yeah. So do you think, is it the kind of thing where, if you're suffering from something like entry stability, you might be trying to keep the rear of the car a little lower to keep the diffuser working a little harder on corner entry? Is that the sort of thing you're typically trying to do?
Exactly.
Yeah.
Yep. It's a pretty powerful adjustment. Where on a car that's not aero sensitive, I'd be going the other direction, looking for some mechanical grip there with less. But that's not how this car responds.
I was interested in what you brought up before when we were talking about shock pots as well, talking about looking at bump stop engagement. Do you have any ability to change the bump stops, or the bump stops homologated, or you can change packers, or to sort of change that bump stop engagement point?
Yeah, the bump stops are open. So it's an important aspect of it.
Based on the length of your answer there, I'd say you guys are probably mucking around with bump stops quite a lot.
Yeah, it's important for sure.
That speaks volumes for not having said much.
For sure. No, for sure. Well, yeah, certainly in my experience running, relatively high downforce GTs and stuff, bump stops certainly one of those areas where there's a lot of gains to be had. And I think if you've got the ability to change that, change bump stops, whether it's changing the material of your bump stops, engagement points, that sounds like a pretty useful tuning tool, particularly if you're really locked in on things like your dampers and your springs and stuff like that, because obviously the bump stops can become pretty influential. And I think maybe for a lot of people, particularly maybe people that don't do this professionally, maybe bump stops get a bit overlooked as far as how powerful they are as a tuning tool. What do you think?
Yeah, I mean, honestly, before this car, it's not something I really ever had to work with, because I had, for the longest time, had infinite control on spring and wasn't really working with the high downforce cars like you were talking about, Tim. But it's been a cool new chapter for me to have an opportunity to really work with them and try to understand them and see the impact in the handling. Yeah, it's been very important. Absolutely.
Could you without giving away any secrets here, but could you talk generally maybe about some of the basics of what sort of parts of the car handling you might want to be influencing by making a bump stop change, or whether that's to control just the the ride height in the straights, or is this actually more a mechanical thing as well? Like you're using it to control transient balance and entry balance and stuff like that because the front's engaged in the bump stops and the rear isn't, for example?
Yeah, that's where it becomes really powerful, is in the transients. And allows us to change that roll stiffness distribution at corner phases where we may want to have more stability or more confidence, and it's also speed sensitive. So typically with the higher speed corners where we want some more confidence in the car, we may want some more front roll stiffness distribution to move the balance slightly towards understeer, and that's something we can do with that. But the flip side is it's easy to get it wrong as well. And if the engagement's not at the right time, it can upset the car. If you have too much engagement in some of the low speed stuff, you can hurt the mechanical grip. So yeah, I think it's a lot to get it right. Where with the when you're running just a mainspring without it, no matter where you put the car, that is what it is, and you're not going to have these variations, and it's not going to be as sensitive from maybe one corner to the next. Where with the bump stop, I think you need to understand how it's impacting the car.
I I'll pull it back just a little bit, because some of our people listening probably haven't really considered bump stops in an aero sense. And from a road car perspective and a modified road car taking it to the track, the bump stop's sort of something we tend to probably try and stay away from. So I think it's just worth mentioning here. What we're talking about is with high aero downforce, the ride height of the car basically gets compressed. The car gets lower at the end of a long straight. So you're purposely actually running the car down onto the bump stops to control that ride height and these higher speed sections. So we don't end up with the car bottoming. You obviously already mentioned that your spring rate limited as well, but if you didn't have the benefit of being able to tune these bump stops and use them as a tuning tool, you'd have to fit a spring that was stiff enough to keep the car off the track at the high speed sections, and that would adversely affect your mechanical grip in the low speed stuff. So that a really sort of brief two second rundown on what we're talking about here.
Yeah, absolutely.
For sure. And I think in my experience, I'm not going to push you for what bump stop brand or compounds you're using or anything, but I found things like polymer-based bump stops. It's something that I found can degrade quite a lot over time as well, and they actually end up becoming a little bit of a consumable item. What you start with on the first day you fit into the damper versus if you run them for half a season, both in terms of their stiffness and their internal damping properties as well. Is that something you've come across, or you guys changing bump stops so often it's not something you tend to be hurting them too much?
I haven't run them long enough to get to that point. I think we've been cycling through enough different variations of it that we haven't lifed any out, but that's something that I hadn't really considered, and makes a lot of sense when I think about it. So maybe we need to start rating them relative to life.
Just added to your workload there.
We'll send you a bill for the advice.
Yeah, appreciate it. I'm always learning from Tim.
So one of the things I thought would be interesting to get your perspective on, obviously you've run lots of different cars at this point throughout your career. You've got a new car, whether you've just bought it from the manufacturer or whether you've just built it. What's your sort of process? You're taking this thing to the track for the first time. What's your process for learning this thing and setting it up, and what sort of things are you looking for? I mean, are you looking at the data a lot? Are you looking driver feedback? I mean, obviously it's both of those things, but what's your process for taking a new car to the track and shaking it down for the first time and starting to learn it? So
first thing starts at the workshop. Try to go through and understand the car. So we're going to do our bump sweeps relative, like toe change relative to ride, understand the toe curves of the car, measure, motion ratios, all that stuff, understand those values, put it into our spreadsheets, and, figure out where we expect to be on the damping ratio, shocks on the dyno, run through the adjustments, understand what the adjustments mean and how powerful they are, see how that aligns to where we would have valved the car. Look at our optional spring rates and prepare the car on the pad to, hopefully we have enough spare dampers that we can set up all the optional springs, have everything ready so that we can do, A to B comparisons, And then, engine dyno, see the power curves, understand where all the shift points are going to be, and what its characteristics are. And then from there, we get to the track. Driver feedback is such an important tool, and you definitely need. I think there's a lot of value in having that pro in the car, giving that feedback, and having a relationship with that driver that we can trust each other and understand what he's saying and what he needs, and then work through all the adjustments. Start with the basics. First thing, get tire pressures right. It may sound so simple, but sometimes can be. It's such an important characteristic and performance part of the car that you can really get excited about turning knobs and stuff. But if you can't get a baseline and have a consistent tire under you with the right pressure in it, well, then all of what you're doing is skewed. And I think that's one of the biggest challenges in what we do is we're trying to compare and evaluate changes in a constantly changing environment. We have a track that's constantly changing, whether it be from ambient conditions or rubbering in or dirt coming on, or there can be 100 different things that track has changed from one lap to the next. And, we want to, over, 3 laps, come in, make a change, go back out and get a true read on whether it was better or worse. And that can be difficult when you have all these variables, the main one being the tire, I find. And, maybe I'd want to go to a circuit with low tire deg if I'm looking to understand the car, where at least I can have a set of tires do the same thing for 10 laps instead of 2. Because you can go to Laguna and try and do this, but I can tell you there isn't any knob on the car you're going to turn that's going to make it better than what you're losing in tire performance, right? So
yeah, for sure.
Yeah, maybe that's part of my requirement for first understanding the car as we go do it at a low deg track where at least the tire can be consistent, and then we'll start working through our changes. But I like to start with the manufacturer's recommended setup sheet. The people that are heading up these programs, I've worked with a lot of different manufacturers now, but they're all really smart people that are doing this, and they put a lot of effort into producing, good base starting points. So I think it'd be foolish to not take their word on that while you're just starting to understand the car. So that's what I would do. I'd go out there at the base settings with the understandings of the stuff we worked through at the workshop to know what the changes that we're going to try are actually doing. And then look to the data and look to the driver feedback. Hopefully they correlate, and start working through the stuff and try and find some pace.
So as far as your setup that you go, every racetrack you go to, every race event, you're obviously always learning something, whether it was a different adjustment you tried on the car or something maybe different with a tyre compound or a tyre pressure. But how much do you find that your setup is evolving from track to track? Like, I assume that you guys are obviously running on tracks that are varying a lot as far as their characteristics. So there's presumably, each track needs something a little bit different. But do you find yourself finding a good setup at track A and really just taking a slight evolution to track B, or are you really kind of starting again each time you head to each circuit for each event?
I'd say the biggest thing has been learning the surfaces of the different tracks and what they want. There are tracks that you struggle to make temperature on, and there are tracks you struggle to keep the tire on. And then adjusting the setup to suit that has, for me, produced the best results. So yes, the car is changing from track to track, more with alignment stuff than with spring. Because again, we found that seems to work well wherever we go, but definitely on the alignment side, we're constantly we're making changes from one track to the next for sure.
Mm-hmm, mm-hmm. And one last thing I wanted to talk about before we wrap it up was you've worked with a couple of different tires. Well, I'm sure more than a couple, probably 3 or 4 different tire suppliers throughout different race series that you've been part of. How do you find that relationship changes? Like, obviously you guys are working with Michelin these days. Do you get a lot of information from the tire manufacturer? Do you get a lot of support or help, or is it more about them just trying to make sure that you're not blowing their tires up?
We're not getting much engineering support with the tires, but I find that's been the case for our Pilot Challenge or its equivalent namesake over the years, whether it's been Continental or Michelin, or when we ran in World Challenge with Pirelli. There's some information available, but it's not extensive. Budget unlimited, it would be pretty awesome to go run our own tire testing and produce that data for ourselves and our tire size, and have all of that. But that's not where we're at this point.
So what sort of information would they be giving you? Is it a case of, obviously you've got your pressure limits, your camber limits, but are they giving you like vertical stiffness data about how, what the effective spring rate of the tire is or anything like that? Or what are they giving you?
Yeah, vertical stiffness is available, and that's about it.
Yeah.
So no camber versus slip or target slip angles or anything like that.
Mm-hmm.
So nothing to be able to produce like a tire model.
Well, for sure. Yeah. But I think this is the situation that the vast majority of people racing, whether they're doing it professionally or not, are probably finding themselves in. It's only really at the really high end where you've got not just budget, but people available to use that data as well. It's all very well to have it. I've certainly been involved in a number of teams in my career where we had all sorts of stuff like that. We didn't do much with it.
Sure. Yeah.
Do you think, if we start to wrap this up a little bit now, Andrew, do you think, as far as an overall discussion of how to approach setting up a car and car setup philosophy in general, anything else, the topics you think we sort of missed or you think we should touch on before we start wrapping up?
I'd say one of the biggest things is to not be afraid to make a big change. That's something that I've struggled with at times. And because you only get so few opportunities to make a change, at least with the schedules we run in, I find I have to push myself to make a big swing, to make sure it's something the driver's going to feel, to make sure it's something that's going to show on the data, so then we can at least understand the direction that it forced, and if we need to find a compromise in between, then we can make an educated decision on that. But the reality is, 3-4 clicks are typically not enough that they're going to produce something significant. And when you only get really 1 or 2 chances in a session to make a change, make it count and learn something from it. And don't be afraid to go too far, to at least make sure that the change shows its true direction. Or that if it's completely not powerful as well, like go big enough that it teaches you something.
Is that one of those areas where working with a better quality of professional driver who's a bit more sensitive to, as you say, maybe 4 clicks of adjustment can allow you to sort of see that direction without needing to go so large? Or even with a pro driver, you still want to make a significant change like that?
I think it comes back to like we were talking about with the tire degradation again. Because unless you have the budget that you're running sticker to sticker to sticker comparisons, that 3 clicks could be lost in the tire performance from the in-lap to the out-lap.
Yeah.
And then it just gets skewed, right? And the other thing is, I think even the best pros, you still want to help with their confidence in what they're feeling in the car. And as an engineer, probably the best way you can do that is make sure the change is big enough for them to feel it. Because if you just keep throwing these small changes at the driver and saying, okay, tell me, and it's not doing anything, you're not helping their confidence either, right? That I really feel like that trust in that engineer-driver relationship is really important. I never try to put my drivers in a situation where, like I've never once told a driver to go out and try something without making a change. Like if I'm asking them to try something, it's because I made the change. Do you know what I mean? Like, It's easy as an engineer to,
as far as not tricking them with a blind change or something like that.
Right. I want that confidence to be there to know that, every time I say I'm doing something, it's in their best interest for them to, hopefully find performance and not put them in an awkward situation.
Yeah, I mean, I think there's plenty of times where you do make a change and maybe it's not big enough, and the driver does feel like you say, "Oh, how was that? How did that feel?" And turn next, whatever it was, and they probably feel a lot of pressure to say something. These people they're professionals, but they're also people too. Like they feel the pressure to say, "Oh, yeah, that was much better." It really helped them. The entry stability that was great, but maybe there was nothing there. So I think you're right. As far as not giving them a fair go as well.
Sure. Yeah.
So I think if we sort of start wrapping it up here, Andrew, what's the future look like for AWA at the moment? Obviously, you guys have got a fair bit of the season left to run. What's on the horizon for you guys?
Yeah, so our customer has expressed interest in continuing on with the McLaren program in 2022, and potentially further than that, which is outstanding. Working with Ori has been fantastic, and I'm excited for that to continue. He's an absolutely great guy, does a great job in the car, and allows us to do things the right way. And I think the results and success are speaking to that. So super grateful for that opportunity, and keen to continue that. We've been having some discussions with the idea of the second car with some other drivers. So we'll see where that goes. But at the end of the day, we have the program we're running and commitment to continue that. So I want to make sure we do the absolute best job we can with that and keep that going.
Fantastic. One of the things I think this podcast is going to be great for is maybe for people that are interested in working in the industry professionally, maybe don't exactly know how to crack into it. It does seem like a bit of a scary beast from the outside sometimes. So it'd be great if you could give me your perspective on, if you were talking to a younger Andrew right now that was interested in getting to a position similar to what you are, what would your advice be for what sort of path to follow and things to think about along the way?
I think from the schooling point of view, the Formula SAE is still invaluable. I think what you can learn there will absolutely get you a good start in the sport. And then I think when you're just looking to get into it, every role on the team has lessons to learn from, whether it be tires or fuel or even pit equipment setup, whatever the role may be. I think if you have an opportunity to get into any of those roles, take it, because you're going to learn something that's really valuable. That even if your goal is to be a race engineer, well, when I look back, if I didn't understand each process, hadn't done each process, I wouldn't be able to do what I do today, at least to the same capacity. So I think engineering and strategy roles may be few and far between, but I think there's always teams that are looking for people to get in at the ground level and do some of the hard work. And don't be afraid to start there. And there's a lot to learn.
Great advice. Anything else from you, Andre?
No. I think we're good.
Fantastic. Well, if people want to check you guys out, see a bit more what you guys are doing at AWA, where would they be able to find you on the socials, Andrew?
Yeah, AWA Racing Team on Instagram and on Facebook, and then our website's awa.team.
Fantastic. Awesome. Hey, look, I really appreciate your time today. It was a really interesting discussion. As always, learned something from you as we go. So I really appreciate your time.
Thank you so much, guys. Really appreciate it.
Awesome.
All the best for the rest of the season.
Thank you. I'll try and keep this going.
Very good. All right. Thanks, Andrew. Cheers, mate.
All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.